Hello children. So yesterday we completed one of the compounds of nitrogen, that is ammonia. Today we shall check for the next compound, that is nitric acid. Nitric acid, the formula is HNO3. So let's check the preparation, the lab preparation of nitric acid. So the lab preparation, you are taking vapors of sodium nitrate and concentrated H2SO4. So you are heating the vapors of sodium nitrate and concentrated H2SO4 and it gives sodium hydrogen sulfate and nitric acid is produced. The reaction takes place in a glass retort and the vapors of HNO3, it is cooled. So glass retort means where the distillation process occurs. So this is the lab preparation of nitric acid HNO3. Let's check on a large scale preparation how it is prepared. So 3 steps are involved and the process is called as Oswald process. It is Oswald process. So what is it? Ammonia is taken and it is treated with amphoteric oxygen. Correct? Ammonia is taken, NH3. It is treated with amphoteric oxygen. Amphoteric oxygen means which can react with acids and bases. Correct? The meaning of amphoteric is which can react with acids and bases. Catalyst is platinum or rhodium. 500 Kelvin temperature is maintained and 9 bar is the atmospheric pressure. At that time we obtain nitric oxide and water molecules. Nitric oxide further it is treated with oxygen to form nitrogen dioxide. Nitrogen dioxide on hydrolysis it gives nitric acid and nitrogen oxide. So this is a 3-step process for large scale preparation of nitric acid and the process is called as Oswald process. 3 steps. Check for the conditions. Platinum or rhodium is the catalyst used, 500 Kelvin temperature and 9 bar is the atmospheric pressure maintained. So just make a note of the preparation of nitric acid and we'll move to the next topic, properties of nitric acid. Yes, so check the properties of nitric acid. It is a colorless liquid and freezing point is 231.4 Kelvin and boiling point is 355.6 Kelvin. Lab grade HNO3, that means the nitric acid which we are using in the lab, it is approximate 68% by mass and its specific gravity is 1.504, that is the density. Strong acid, it is a strong acid we know and it can react with water. So how it will react with water? Hydrogen here it is positive, nitrate ion that is negative, water has 2 parts, correct, and oxygen it is having a lone pair of electrons, 2 lone pair of electrons. So this lone pair of electrons it will attach with H plus, negative and positive. It forms H3O plus and nitrate ions. It is also a strong oxidizing agent. That means it attacks on metals. All the metals it will attack except noble metals such as gold and platinum. So noble metals such as gold and platinum, they do not react with HNO3. They will not dissolve in nitric acid, but they will dissolve in a solution that is called as aqua regia. Okay, we'll see that reaction. Aluminium and chromium do not dissolve in concentrated HNO3. That means because it forms a layer of oxide. Aluminium and chromium, they will react with the oxygen and they can form a layer on its surface. So it becomes a protective layer for them, aluminium and chromium. So further attack of HNO3 is not possible, because already a oxide layer, that which is the protective layer, is formed on the surface of aluminium and chromium metal. So let's check about this. Gold and platinum, it will not react with a strong oxidizing agent like HNO3, but it can dissolve in aqua regia solution. So we'll check that. Just make a note of these properties of nitric acid. Yes, so I have written here. In the previous point we discussed, that is, noble metals such as gold, platinum, they do not react with nitric acid. Though nitric acid, it is a strong acid. So these elements, they will dissolve in aqua regia. And what is aqua regia? It is a mixture of both the acids, HNO3 and hydrochloric acid, nitric acid and hydrochloric acid. So it will form nitrosyl chloride. The reaction mixture, it forms nitrosyl chloride. Along with that, water is the byproduct and chlorine vapors are produced. These vapors, when it passes through Au, that is gold, it forms gold chloride, correct, auric chloride. And platinum also reacts with the chlorine vapors, it forms platinum tetrachloride, PTCl4. So the chloride forms are obtained. So directly with HNO3 alone, gold and platinum, noble metals, will not react. So we are taking the reaction mixture which forms nitrosyl chloride and chlorine vapors. So the metals can react with the chlorine vapors and get converted to their chloride forms. So this is aqua regia mixture. So any metal which is not reactive with that acid, particular acid, whether it is concentrated or dilute, we can dissolve that metal in aqua regia. So make a note of this. So check the reactions of nitric acid and some of the metals. So two metals I have taken, that is copper and zinc. All the equations are balanced here. What you have to learn is copper reacts with the dilute HNO3. It forms copper nitrate, nitrogen oxide, nitric oxide and water. Check the dilute equations first. Zinc reacts with the dilute HNO3. It forms zinc nitrate, water and N2O. Now see the concentrated reactions. Copper reacts with concentrated HNO3. It forms copper nitrate, nitrogen dioxide and water. Zinc reacts with concentrated HNO3. It forms zinc nitrate, water and NO2. So if you check the two equations with concentrated HNO3, if you check the reactions with concentrated HNO3, correct, the products, the byproducts formed, it is same, water and NO2, water and NO2 and particular nitrates, correct, zinc metal, so zinc nitrate, copper metal, so copper nitrate. Now the question is, with the dilute HNO3, copper and zinc will react, but check for the products here. Copper nitrate, here it is forming zinc nitrate, water, water, but check the oxides, what it is forming, NO, N2O. So the nitrogen oxide, that is different in dilute cases, right, when HNO3 is taken in the dilute form. So what is the reason is, check for the metal, which is a reactive metal, zinc and copper. Two metals I have taken. So which is more reactive? You can check the metal reactivity series. So zinc is more reactive. Correct? In the metal reactivity series, if you check, zinc is more reactive than copper. Copper is less reactive than zinc. So it depends on the metal. The product depends on the metal. If it is a more reactive metal, then it produces N2O, dinitrogen oxide. If it is a less reactive metal, it produces nitric oxide. Correct? So please make a note of this. With the concentrated acid, the metals will give the same byproducts, but with the dilute nitric acid, the byproducts are not the same. Water is the same, but the oxides, nitrogen oxide, it differs. So check whether the element or the metal, it is more reactive or less reactive. Less reactive means it will form nitrogen oxide. More reactive, it will form dinitrogen oxide. Make a note of all the equations. It is balanced also. So now let's check the reaction of nitric acid with non-metals. Correct? Previous reactions was nitric acid reaction with metals. Now let's check nitric acid reaction with non-metals. Correct? So iodine, it is reacting with nitric acid and it forms iodic acid. So I2 iodine is oxidized because HNO3 is an oxidizing agent, strong oxidizing agent. So iodine is oxidized to iodic acid. Same way carbon is oxidized to carbon dioxide. S8, that is sulfur, it is oxidized to sulfuric acid. P4 phosphorus, it is oxidized to phosphoric acid. Correct? And you can check in case of non-metals, when they react with HNO3, all the byproducts, they are the same. So check the next test, brown ring test. It is based on the practicals. Okay, it's a practical question. So in the practicals of grade 12, you get salt analysis. You will get salt analysis where a sample of a salt will be given to you. In that sample, you will have one positive radical and a negative radical. And you have to perform some test, and based on that you have to identify which is the positive radical and which is the negative radical in the sample given to you. Correct? So one of the test is brown ring test, and this test it is performed to identify whether the negative radical in the sample given to you is nitrate ion, NO3 minus. So see the test over here. What is the test? So whatever a sample given to you, you are taking a pinch of the sample in the test tube. Pinch of the sample you are taking in the test tube. Into this sample you will add a little of distilled water, and into the same mixture you will add few drops of concentrated H2SO4. Concentrated H2SO4. Correct? And what you are adding further into this, one more thing you will add, that is freshly prepared ferrous sulfate solution. It should be freshly prepared. It will be prepared in the lab. So you have to add FeSO4. So how is this test performed? You are taking a test tube. Into that you will take a pinch of the sample given to you, add distilled water and concentrated H2SO4. Then you add freshly prepared FeSO4. Correct? So when you add, you will get a brown color ring. you will get a brown color ring. Correct? If you get a brownish color ring, then the presence of nitrate is confirmed. A brown ring will be formed on the surface. Okay, brown color ring. Ring means on the surface a layer. It will be formed, and that means nitrate ion is present in the sample given to you. So you have identified the negative radical. Now the reaction for this test, how it is done. So nitrate ion, I have written the ionic equation here. Into that you are adding FeSO4, so Fe2 plus, correct. Into that you are adding acid also, H plus, okay. It is an ionic equation. This will form NO, correct, nitric oxide, Fe3 plus ions and water, correct. Fe2 plus to Fe3 plus, it oxidizes, and Fe2 plus, it is oxidizing nitrate ions to nitric oxide, and further it is also forming Fe3 plus. Now in the reaction mixture you can see Fe3 plus, it will react with water molecules. So it forms FeH2O whole 6 complex and NO. Further it will react to form this complex, that is FeH2O whole 5 NO 2 plus. The entire complex is having valency of 2 plus. Correct. What is the name of this complex? It is the brown ring formula. The brown ring substance which is formed, its formula is FeH2O whole 5 NO. What is the name of that complex? That is penta, because 5 are there, so penta, that will be the name, penta. Water will be written as aqua, so penta aqua. NO, it is the nitrosyl, so penta aqua nitrosyl. Fe2 plus, Fe2 plus, here also Fe2 plus, right. So penta aqua nitrosyl iron sulfate. So this is the formula of the brown ring substance which is formed, and it is the name of that brown ring substance. So this is how the brown ring test is conducted in the lab, and it's a practical based question. Just make a note of all these things and the equations also.